Now let's look at the example problem from LeetCode, XOR queries of a subarray. So we are given an array of positive integers, and there's an array of queries that we want to answer. Um, so each query is given by Li, and Ri. Um, So the query asks us to compute the XOR of all the elements from Li to Ri. So that means starting from array of Li, XOR will Li. I guess actually technically this should be Li plus 1, where the plus 1 are not in the subscript. So from Li to Ri. And we want to return an array of result. So let's look at the example. The array is 1, 3, 4, 8, and the first query is 0, 1. So that means we want to we want the XOR of the first two values, 0, 1, 2, 3, 1, and 3. So 1 XOR 3 gives 2, because in binary this is 0, 1, this is 1, 1. You XOR the unit bit, the 2, 1 XOR becomes 0, so it becomes 1, 0. So 1, 2, XOR 3 and 4, that's 1, 1 with 1, 0, 0. That give XOR of 1, 1, 1, so that's 7. So everything, 0, 3 is everything XOR together, so which turns out to be 14. So that's what they ask us. In this kind of, let's look at the parameters. So the array length is 3 times 10 to the 4. And each array is 10 to the 9. So then that means yeah, so I think this is less than 2 to the 30. Yes, less than 2 to the 30. And the query length is 3 times 10 to the 4. So for every query, if we do it in the brute force fashion, we just XOR all the things together. Then the complexity for answering one query is Ri minus Li. So in the worst case, that will be the same as the array length. So the complexity is the query length, number of queries, times the number, the array size. So it's if we call this big N, call this Q, complexity is the NQ. So this is a little bit too big. So when the parameter are like that, they generally don't expect you to, because it's getting close to 10 to the 9. So that's going to be not efficient enough. So how do we speed this up? In general, when we try to speed things up, oftentimes what we do is we look at whether we are duplicating some computation. So then if we're duplicating that, maybe we can avoid duplicating that. So as you can see, we are duplicating a lot of computation, right? So here we for this query, we XOR the first two, we XOR the second one, and then the last one we XOR everything again. So if the array is long, then we may be XORing the same segment again and again. Now, is there a way to avoid that duplicating that computation? Oftentimes, we avoid duplicate computation by storing the result so that we can later reuse it. So then we don't need to compute it again. So in some sense, that's this concept of data structure is about. So we want to figure out a way to store the data so that we can use them more efficiently. So here we want to store the intermediate result so then we can answer a query more efficiently. And at this, we need to use one property for XOR. So bit by bit, XOR have the property that for any value A XOR with itself is a 0. So because that's XOR is, so 2, 1 gives us 0, 2, 0 gives us 0. So when we have A XOR A, every bit is the same. Either they're both 1 or both 0, so we get all 0. And then because of that, if A XOR B equals C, then A XOR C equals B. So one way to see that is XOR is associative. So if I have a XOR B XOR C, then I can do them in any order. So I won't actually prove that here. It's easy for you to verify yourself. But given that, then if we XOR A on both sides here, we get A XOR A XOR B equals A XOR C. So by associative, then I can do A XOR A first. So then I get 0. And 0 XOR anything equals that thing itself. So I guess that's a property that I should add for any A XOR 0 equals A. So the reason is 0 XOR 0 will give us 0. If a bit in A is 1, then XOR 1x0 will give us 1. So we'll get exactly A here. So because of this, XOR is often used in encryption, because if you think of one of them as the key, say A is the key, B is the message, and then C is the ciphertext. And then given the ciphertext and the key, you can easily recover the plaintext. So then XOR is actually used in encryption a lot. Of course, how to generate the key is what's make it secure. So you want to make sure that people cannot figure out what will be the key here. So in fact, in one very simple cipher known as one-time pad, you literally just do this. So you literally just XOR your key with your message. But the difficulty there is the key need to be very long. So in general, we will have a shorter key, and then we somehow expand that to a long sequence, and then we can use XOR. So this is known as a stream cipher. Okay, so going back to this problem, we can use this property by computing and storing the XOR of all the prefix of the array. So we can compute the XOR, we can compute the value of 1, and then the XOR of 1 and 2, and then the XOR of 1 and 4, and then the XOR of 1 and 8. So then if we want to know the XOR of 4 and 8, then we simply use the XOR of the whole thing, 1 through 8. So 1 through 4, 8 XOR together, and then XOR that with the value of 1, 3, the prefix. Essentially x3, 1 and 3 are XORed twice, they cancel out. So then what we get is the XOR value of 4, 8. So by storing the prefix, the XOR of all the prefixes of the array, then we can answer each query by looking up 2 values from the array and then XOR them. So we get constant time to answer each query. And the prefix can be computed in time linear in the array size. So then now the complexity become order n plus q. So the array length plus number of queries instead of n times q. So yeah, so this is code that I have written. So I mentally debated a little bit of whether to do live coding. So I think this is fairly straightforward. So I'll just explain the code that I written before. So I use this XPS array to store the XORs of a prefix, the multiple value of that. So I use S. So in general, when I do this prefix array, I make the prefix array. So this this is often known as the prefix sum array. So even though here we are not doing sum, instead we are doing XOR, but abstractly it's the same. So oftentimes we can store the sum of all the elements in the prefix in this array, and this will enable, for example, a range sum query, and it also enable other things to be done efficiently. So this is let's call this a prefix sum, even though it's really prefix XOR. So these prefix sum things should have one more items than the original, because we want to start with 0. So the 0 means the empty prefix. It doesn't include any item. So that has a value of 0. So then the last one includes all n elements. So XPS I essentially is the prefix sum of length I. So the prefix sum is computed by just going through each element, and then the next one is the previous one here XORed with the ith element. And then we answer the query. So we have this answer is the one will be returned. For every query, we simply compute the XOR. The Q0 and Qi are the beginning and ending index. So Q0 we will use that to index into the array. Yeah, so if Q0 is 0, that means we want to start from the first element. Then if we want this part, then what we want to do is we want the prefix of 1, 3, 4, and then XOR with the prefix of just 0. So we cut off the previous one. So we don't need any special code to handle that. We just put the Q0 here, and that works because we have this array being n+1 elements. When we say 0 to 2, for example, here to go here, then we really need to look up the element for 3, XPS 3. So because that is the prefix of the first 3 element, because we have something for the empty prefix. So this need to +1. And I believe this will work. Yeah, I think this one has been submitted before.